P and Q are distinct primes less than 7, so that means they could be 2, 3, or 5. What's the largest possible value of the highest common factor of 2p squared q and 3pq squared? Okay, well, what we can see is that p is going to go into both of them, and q is going to go into both of them. So if I divide through by pq, I'm left with 2p over here and 3q over here. So there's only a certain number of permutations we could do for this, but here's the thing. If we let p equal to 3, then I'd get an extra common factor that I can take out because I'd get p here and p here. It would then make sense to let q equal to 5 because I want to make it as big as possible. Although you could argue that if I let q equal to 2, I'll get another common factor. But let's see what happens here. I would get pq times 3, which would become 15 times 3, so 45. So this is obtainable. If I went with p equal to 3 and q equal to 2 to get that extra common factor, then I'd get 6 times 6. And even though I've managed to get a larger number on the right, the number here is much smaller. So that's not going to be as large. Then let's just look at what happens if q is equal to 2 to get that common factor. And then let's make p equal to 5 to maximize it. So then I'm going to get 10 times 2. Okay, the 2 just really, doesn't work out. So those are the different ways of doing it that make sense to try and make p and q numbers such that we can use them again. Like you don't want to make p equal to 5 and q equal to 3, for example, because then you just miss out on the extra common factors inside here. So it makes sense to use 3 and 5. The maximum is going to be 45.